Okay, Mr. K here, talking about automotive electrical safety. And there's going to be kind of two main parts to this presentation. There's going to be the basic part, which will be review for most people watching this. And then we're going to talk a little about electric vehicles and hybrid vehicles and safety around those, because that is a completely different ballgame. So let's jump into it here. The goal in this presentation is so that you, A, don't burn the car down, as it looks like that's what's happening in this top left picture, and B, so you don't hurt yourself. So non-electric vehicles, so I'm just talking conventional vehicles, like 90% of what's on the road, okay, just plain old 12-volt battery type vehicles. One second, I need to get my presentation preview pulled up on my other screen. Okay. Don't touch the positive and the negative together. Okay. On the battery, there's 12-volt battery. It's only 12 volts in houses, 120. That's AC, battery's DC, but that's for another day. But just keep in mind that those are opposite polarities on that battery. And if you touch those two together in any way, you drop a screwdriver or a wrench and it falls across them, or a wire touches each one of those, you're going to get fireworks. So, and it could even blow up the battery, and you could have acid everywhere, including all over you, which battery acid is bad stuff, which if you want to learn about that, you can watch the MSDS lecture. But anyway, so basic rules, 12-volt system, don't touch positive and negative. You'll create a direct short. You can melt a wire, start a fire, explode a battery. Disconnect the battery before servicing a vehicle if it's got remote start or airbags. I always drill that into everyone's heads, that car comes in to get an oil change and you're in the middle of it, and it's a, say $60,000 Cadillac or Mercedes, and grandma's in the waiting room and she moves a little bit and puts pressure on her purse or leans on it and it hits the remote start key. That car is going to start unless you've disconnected the battery or taken some other kind of action. But it doesn't matter. Keys aren't in it. Doesn't matter. That car is going to start. And you want a $60,000, $80,000 Mercedes starting when it has no oil in it and it's up on your lift. Let you make that call. So disconnect the battery. Don't replace a fuse with a higher amperage fuse if you don't have the right one. Just leave it out or put in a smaller one, if anything. We'll talk more about that in another slide. Use caution on the ignition system, which emits dangerous voltage. And we'll talk a little more about that. Okay, here's a fuse block in a vehicle. You can see we've got different values, 5, 15, 10 amp fuse. Here's a 20. I don't see any 30s anywhere. Here's a 7.5. Okay, that's the amperage that's the rating for how much amperage can flow through that fuse before it blows. Remember, the fuse is made to protect the wire. So if the fuse blows, that's so that it doesn't melt the wire itself and cause a bunch of damage or start a fire. So you take that 15 out and you stick a 25 right there in the 15 slot, because that's all you've got as a spare, which in this fuse block looks like that's all the spare they have is a 10 and a 25. So if you stick a 25 in there and then that wire continues to have a short, it's going to melt the wire, because the wire is now the weak link, not the fuse. That's not what you want. Okay, stepping it back here to, looks like 60s or 70s technology here. And we're gonna talk about ignition systems, because in an old car, there's probably only one part of the electrical system shock-wise that can hurt you, and that's this here. So the ignition system powers the spark plugs. Okay, there's your low voltage coming in from the battery on both sides of the ignition coil. Here's your high voltage. These big thick cables are what holds that high voltage. That that shoves high voltage in here. Distributor cap then distributes it to each spark plug at the correct time. So if you see these on an old car, you see these on an old car or on any car, you don't want to touch that while it's running. As soon as you shut the engine off, you're safe. And that's called a distributor type ignition, because it has a distributor. A little bit newer, we're going into probably 90s era. They switched to coil pack ignition. Some people call it distributor-less ignition also. Instead of a distributor, you've got coil packs. 1, 2, 3. It looks like this engine has 3 coil packs. If I'm not mistaken, this might be a GM Chevy 3100 series engine, like in a Buick, 90s Buick or Chevy Corsica, something like that. So spark plug wires, again, coil packs send out high voltage. And when I say high, I'm talking maybe 10,000 volts. Shove that down through these wires, go into the spark plugs. Stay away from those while the engine's running. Newest design, coil on plug ignition. There's no more wires. It's now the coil puts out that high voltage and sends it straight down into the spark plug inside the motor. Ups and downs to this design for a lot of reasons, but we're not talking about that today. We're talking about safety. So these, you should be pretty safe. Just don't get your fingers in this area while it's running. And even that, you should be safe, but it could arc out at you if it's in bad shape, the insulation's in bad shape. Otherwise, not as much to be afraid of on these particular setup or design. Okay, at this point, I'd like you to pause my video and watch this video. You can either type this in your search in your URL, or you can go to YouTube and search for dangers of dealing with electric cars, and you're going to see a news release about how they can start on fire and just keep burning. So go ahead and watch that now. Okay, should have just watched that video. We're going to move on. If you open the hood of a electric car, I think this is a Chevy Volt, or it might be a Chevy Bolt, can't remember. You're going to see orange cabling. Okay, that orange basically means stay away if you don't know what you're doing. High voltage that can kill you. That's what that means. That's what I mainly want you to get out of this presentation. Stay away from the orange if you don't know what you're doing. If you think you know what you're doing or you've been trained, you're going to work on it, here's what you need. Face shield, hard hat is what's recommended. Some kind of lab coat that's fire resistant. Rubber gloves with leather gloves over them. These rubber gloves, by the way, need to be rated for the correct voltage that you're going to be working around. We're going to get into that in a minute. Remove jewelry, metal watches. Okay, another thing is the rubber gloves need to extend at least a ½ inch beyond the leather, because the leather can still conduct some electricity. So you don't want to be, you can still be shocked if this rubber glove is right up here. You want that cuff to be way up here away from the leather, so that doesn't arc from the leather to your skin. Okay, if you're working on a hybrid system that's, let's say 350 volts, like the new GM stuff is, I think it's 355 volts, you'd be good with a 00 glove. Okay, you might need a 0 class glove if you're working on a higher voltage system. I think it was either Tesla or the Prius can be up to 600 or 650 volts, so you need a better glove. Okay, so safety around electric or hybrid vehicles. First of all, will you remember the orange cabling? Don't touch it if you don't know what you're doing. Also, the same rules as the 12-volt system. You still don't want to swap a fuse first for a bigger one. You don't want to get into the ignition system of the gas part of the motor if it's a hybrid. Same rules. Wear proper PPE when disconnecting the high voltage. Always disconnect the high voltage before servicing any part of the high voltage system. And the manual will walk you through how to do this safely, so use the manual. At this time, I want you to pause this video and watch this YouTube video, working on high voltage vehicles. Okay, and that's gives you a pretty good rundown of what you need to be aware of. Okay, once you've watched that video on working with high voltage vehicles, that's the end of this presentation. It would be time to then work on your assignment for this. Just keep in mind, the main thing I want you to get out of this is that if you see orange, leave it alone unless you know what you're doing. And if you're going to work on it anyway, or you've been trained, you have to put all this equipment on. Okay, that's all. Have a good day.